Good morning, folks. It's Thursday, April 16th, and we just received our email from the Center of Education Mathematics Computing, grade 5-6 problem of the week again. And looking at this problem, we're dealing with, in particular, probability using a deck of cards. And it starts by saying a deck of cards without the jokers has 52 cards, with 13 cards in each of the suits: spades, diamonds, hearts, and clubs. The 13 cards are the 2, 3, and so on up to the ace. And so the first question asks, what is the theoretical probability, or P, of drawing an ace of any suit from a full deck? And so this is where it becomes really important to understand just fractions in general and what the question is asking. So we have to draw this out a little bit. So the first one is, the first key clue is ace of any suit. So we ask ourselves, how many aces are there in an entire deck of cards? Well, there's 4. There's 4 for each suit. And then how many cards are there in a full deck? Well, they've already told us that. That's 52. So if I look at what's the probability, I'm simply going to write that as 4 to 52, or I can also write it as 4 over 52 in that fraction form. And if I wanted to put that into lowest terms, that of course is going to take me down to 1 to 13, or 1 over 13. And so I move on to my next question with A, or with B, and it says after drawing the first ace, if that card is not replaced in the deck, what is the probability, R, of drawing a second ace from the remaining card? And we're putting R in there just to differentiate between the two answers that we have here. And so we recognize at that point, after we've drawn that card, again, it's asking, how many aces do I have left in the deck, and how many cards do I have left? And if it's not replaced, that means that we're talking about there's only 3 aces left, and there's only 51 cards left. And so for B, I would be looking at that probability of 3 to 51. And of course, I'd want to put that down into lowest terms. C, how would your answer to part B change if the first card had been replaced in the deck before the second card was drawn? So again, this is taking that initial ace and putting it back in, answering that question. Again, thinking about how many aces do I have in there now? How many cards do I have in there now? And then finally, we have our extension question, where it says the probability of 2 desired cards being drawn one after the other is the product. And again, mathematical term that I need to understand here, product basically meaning we're talking about a multiplication problem. So it's given me a big clue by just using the word product right off the bat of the 2 individual probabilities. So for example, the probability of drawing 2 aces when the first card is replaced in the deck is P times P, as P being used in the part A question. Again, differentiating between which question we're dealing with. The probability of drawing 2 aces when the first card is not replaced in the deck would be P times R. So again, what's the answer from A times the answer from B in lowest terms? And so what is the probability of drawing the ace of hearts and then a 6 of any suit if the card is not replaced in the deck before the second card is drawn? So again, I need to look at this. I'm going, okay, the ace of hearts. So this is actually a little bit different from my initial A question, in that I don't have 4 choices. In fact, I only have 1 choice out of the 52. And then I have 6 of any suit. But how many 6s do I have available? I would have 4. But how many cards do I have left if it's not being replaced? I'm talking about 51. Putting that down in lowest terms again, of course. And I'm going to multiply those 2 together. and get my answer for D. So a little more confusing. I don't want to give the solution away. The solution always comes with the problem of the week the following week. So if you're working through this with your teachers, or you can even download it off of the CEMC because they'll put it in archives or the previous week's problem there, and you want to look up the solution, you can more than welcome to check that out. So give it a try, see if you can figure it out, and check your answer when they post it up on the website next week. Thank you very much, folks. We'll see you later.